thermal arms belong to that narrow domain where heat becomes a method of negotiation and steel answers by yielding. Their story is best approached without haste, allowing the atmosphere to warm gradually, the way a furnace breathes before reaching its true intensity. Within that rising heat, the Melta gun appears first, a weapon defined not by force, but by the controlled collapse of matter itself. Its internal chambers stabilizing volatile reactions and compressing them into a directed cone that unweaves the structure of armor with a quiet inevitability. When discharged, it does not strike so much as it dissolves the idea of resistance. Metal folds inward, softens, liquefies at the edges, turning protective plating into sagging contours before a sound can fully form. The presence of such heat alters the psychology of battle long before the trigger is pulled, reshaping movement, narrowing choices, and reminding enemies that cover is only a temporary comfort when temperatures reach the point where material memory fails. In enclosed corridors, its exhalation fills the space with drifting vapor from molten surfaces, while in the open, it becomes a method of controlled breach work, carving paths through fortifications and armored hulls with a precision that blends destruction with engineering. And from this single instrument of focused thermal pressure, the lineage of heat-based weaponry extends outward, each successor carrying the same underlying logic. That, in the right hands, temperature alone can redraw the shape of a battlefield. From the concentrated erasure of metal that defines the Melta lineage, the progression toward broader fields of heat feels almost inevitable, as if the same principle once discovered simply searches for larger surfaces on which to inscribe itself. Thus, the heavy flamer emerges not as a refinement, but as an expansion, a weapon built to reshape interior spaces, purge concealed positions, and impose clarity on environments where shadows and cover multiply faster than infantry can respond. Its construction follows a straightforward logic: a stabilized reservoir, a pressure system designed for abrupt release, and an ignition array that ensures the stream leaving the nozzle becomes a moving wall of fire rather than a scattered spray. Unlike the focused collapse caused by Melta technology, this weapon exerts its influence through atmosphere, saturating rooms, corridors, and defensive pockets with a heat so pervasive that it forces movement by removing the air's capacity to be breathed. Flame clings to surfaces and flows along contours, exploiting the architecture of a structure instead of fighting it, turning tight angles, stairwells, and alcoves into conduits for thermal expansion. The psychological effect is immediate and merciless, not rooted in spectacle, but in the instinctive recognition of an element that cannot be negotiated with. No amount of armor fully negates the sensation of rising temperature pressing against plates and seals. Infantry operations within confined networks are shaped around the presence of such a device, for its discharge defines not a line of fire, but a temporary exclusion zone, an area where resistance collapses because the environment itself becomes hostile. The heavy flamer transforms combat from an exchange of trajectories into a slow, sweeping displacement of obstacles, burning away ambiguity and forcing opponents into predictable paths. And once a battlefield has been treated with such heat, it creates the conditions for smaller, more precise tools of fire to operate without obstruction, narrowing the logic of destruction into portable, hand-driven shapes. From the wide, sweeping authority of the heavy flamer, the logic of thermal control narrows again, condensing into something that can be carried through debris, lifted in one hand, and brought to bear in the tightest geometry of battle. The hand flamer is not a diminished version of its larger predecessors, but a deliberate adaptation meant for those moments when a fighter needs immediate dominance over a corner, a breach, or the narrow slit of a bulkhead door. Its reservoir is small, its ignition array compact, yet the stream it releases retains the same essential character. A focused flare that expands just enough to clear a confined angle without overwhelming the wielder. This intimacy of scale gives it a different influence on the battlefield, turning it into a tool for close, almost surgical restructuring of space, driving opponents from crevices where conventional weapons struggle to deliver results. The flame's brief arc forces motion rather than destruction, creating split-second openings in areas too cramped for larger systems, and allowing squads to advance with a sense of controlled inevitability. And once such precision becomes possible, the path opens for thermal solutions that extend their reach, not through volume, but through the integration of heat with ordnance meant to strike machines and armored constructs from a distance. From the compact immediacy of a handheld flame source, the logic of thermal warfare shifts again toward structures too dense to be moved by heat alone, demanding a method that delivers concentrated collapse at distance. The Melta bomb launcher answers this requirement by projecting not a stream, but a stabilized charge engineered to carry the signature Melta reaction into the heart of armored hulls and fortified casings. Its operation relies on precision rather than velocity. The launcher places the charge exactly where metal must fail, allowing the reaction to ignite only upon final contact, where containment ruptures and the concentrated thermal core begins unmaking the target from within. Unlike conventional explosives, the effect does not radiate outward, but bores inward, softening internal supports and reducing structural integrity to a sagging outline of its former shape. This transforms the weapon into a means of disabling vehicles, silencing gun emplacements, or collapsing reinforced gates without the unpredictable shockwaves of traditional demolition. And once hardened structures can be breached at range, the evolution of thermal arms naturally leads toward specialized systems that refine heat into a directed pulse, extending the precision of fire into the realm of long-barreled instruments, built for deliberate, controlled burning. As breaching charges carve their way through armor and reinforced plate, the battlefield begins to demand a different form of controlled heat, one capable of acting not upon structures, but upon hostile presence itself with absolute certainty. The incinerator fulfills this role as a focused thermal sidearm, whose purpose is neither to melt hulls nor to flood corridors, but to deliver a direct, unwavering line of purifying fire against targets that resist conventional methods. Its mechanism stabilizes a narrow combustion stream, hotter and more coherent than that of larger flamers, ensuring that the ignition holds steady even when fired through moving air or across unstable footing. The weapon's burn path is tight, deliberate, almost surgical, shaped for moments when a single hostile form must be neutralized without igniting the environment around it. In dense operations, it becomes a tool of absolute clarity, ensuring that no obstruction, organic or otherwise, retains its shape once the beam settles. And from such precision emerges the need for reach, for barrels long enough to carry thermal discipline further, allowing heat to become not just an instrument of clearing, but a method of shaping engagements across extended lines. From the concentrated, close-held certainty of the incinerator, the evolution of thermal arms stretches outward once more, seeking a form that can project the same irreversible heat across distances where precision must coexist with patience. The Melta rifle embodies this shift, extending the principle of molecular collapse along a longer barrel, engineered to stabilize the volatile reaction before release. Its internal chambers feed into a reinforced focusing array, narrowing the thermal output into a coherent lance capable of carving through plating with a steadier rhythm than the abrupt burst of a standard Melta gun. This refinement allows operators to engage armored silhouettes beyond immediate reach, dissolving their contours with a measured application of temperature rather than a single explosive exhalation. The rifle's weight and length give it a deliberate pace, shaping battles around controlled intervals of fire that pierce hulls, towers, and entrenched positions with the inevitability of slow, methodical erosion. And with range now brought into harmony with precision, heat begins to merge with more conventional weapon patterns, allowing thermal elements to be grafted onto platforms not originally built to carry fire at all, creating hybrids that redefine the boundaries between standard firearms and instruments of engineered combustion. As the Melta rifle extends thermal precision across distance, another branch of development turns its attention to infantry weapons already present in every formation, searching for a way to infuse heat into their existing rhythms without reshaping the entire platform. The flamethrower attachment becomes that solution, a modular extension fitted beneath a standard barrel, enabling soldiers to shift seamlessly between conventional fire and a brief, controlled expulsion of burning fuel. Its reservoir is compact, its ignition system simplified, yet its presence alters the logic of close-quarters engagements, granting any firearm the ability to clear a breach, flush an alcove, or force movement from a concealed angle without relying on specialized operators. The attachment does not aspire to the breadth of a heavy flamer or the surgical intensity of an incinerator. Instead, it acts as an immediate correction tool, a small reservoir of fire carried into places where hesitation would otherwise cost initiative. In ruined corridors, dense foliage, or the half-collapsed geometry of urban devastation, this merging of heat with standard munitions allows squads to reclaim tempo, shaping the battlefield with bursts of flame that fill gaps in coverage. And once fire becomes an integrated component rather than a separate system, the path leads naturally toward heavier mechanisms, where the same principles scale upward into engines capable of reducing fortified constructs to molten frameworks under the sheer weight of thermal output. As fire folds itself into the rhythm of ordinary rifles, the logic of escalation draws thermal engineering back toward weight and mass, seeking a form that can dominate not rooms or corridors, but entire structural bodies. The Melta cannon emerges as this culmination, a heavy platform mounted on armored vehicles and siege engines, built to project the same molecular collapse as its infantry counterparts, but on a scale that bends the geometry of fortifications. Its chambering systems are massive, stabilizing volatile thermal cores through layered insulation and magnetic containment fields that hold the reaction steady until the weapon's full charge is released in a single, overwhelming surge. The effect is not merely destructive, it is transformative, turning armored hulls into sagging silhouettes and collapsing strong points, as if their foundations were made of softened wax. Entire walls lose their structural intention within seconds, their resistance dissolving from the inside out as heat burrows through stone, steel, composite plating, and reinforced supports. Vehicles struck by the cannon do not explode outward. They fold inward, their armor bending like fabric around a flame. On the battlefield, its presence reshapes strategy, forcing opponents to reconsider distance, cover, and even the notion of permanence in engineered defenses. And from this vast projection of heat comes the drive to refine the same principle into more experimental, pulse-based forms, tools that no longer rely solely on sustained thermal pressure, but on measured bursts of energy timed to destabilize matter before it even begins to melt. From the overwhelming surge of the Melta cannon, which reshapes entire structures with a single exhalation of focused heat, the next step in thermal evolution narrows its scope again, not to diminish power, but to refine timing. The thermopulse gun represents this shift. An experimental platform built on the premise that heat can be delivered not as a sustained wave, but as a sequence of sharply timed impulses engineered to destabilize material at its weakest thresholds. Instead of melting armor outright, the weapon targets the microstructure beneath its surface, sending brief, intense bursts that create internal fractures before any visible deformation begins. The pulses accumulate with unsettling precision, undermining cohesion until the target's integrity fails, in a collapse that seems delayed, as if the material surrenders only after realizing too late what has already been done to it. This approach makes the weapon deceptively quiet in effect, lacking the dramatic roar of flame or the molten runoff typical of Melta discharges, yet its influence is no less permanent. In the hands of specialized units, the thermopulse gun becomes an instrument for disabling key structural points, neutralizing reinforced nodes, or crippling machinery without igniting the battlefield around it. And once heat can be shaped into such measured impacts, the path opens for the final refinement of personal thermal weaponry, devices designed not around range or spectacle, but around compact, decisive bursts of engineered temperature meant for the closest and most constrained encounters. As pulse-based heat begins carving invisible fractures into armor and machinery, the progression of thermal weapons returns almost inevitably to the scale of a single fighter's reach, distilling every principle, pressure, precision, collapse, into a device meant to operate at the distance of an outstretched arm. The Melta charger embodies this final contraction, a compact accelerator built to unleash a brief, overwhelming surge of temperature that behaves less like a projectile and more like a point of concentrated erasure. Its internal coil stabilizes a miniature thermal core for only a moment before release, producing a burst that strikes with the immediacy of touch and the intensity of full Melta reaction, collapsing armor plates and reinforced surfaces as if they had been tapped at exactly the spot where they were always destined to fail. The charger's value lies not in range, but in certainty, in tight corridors, in breaches where motion is restricted, in moments when a soldier comes face to face with an obstacle too resilient for anything slower. The device provides an answer shaped entirely around brief, absolute dominance. It does not scorch rooms or hollow out walls. It simply removes what stands in front of it with the quiet finality of engineered heat, doing exactly what it was built to do. And when its discharge fades, leaving only the softened imprint of something that can no longer hold its form, the long arc of thermal weaponry seems to settle into a single, steady truth. That fire, when shaped with discipline, becomes less an element of destruction and more a method of opening spaces where none existed, the battlefield exhaling into stillness after the temperature falls.